Hello, and welcome to Module 7, Statistical Analysis. The goal of this module is to enhance your ability to do the following: understand and use fundamental statistical approaches and analytic programs for research, specifically using Stata statistical software to manipulate data and perform descriptive statistics and comparative analyses, identify types of quantitative data and the most appropriate methods for summarizing and visualizing each, conduct basic data cleaning and manipulation, such as creating new variables and dummy variables, and analyze data by comparing groups and conducting simple and multiple regression. This is the structure of Module 7. We'll begin with how to get started with basic functions in Stata, such as opening and describing data. Then we'll address different sources of data. We'll move into more detailed descriptive statistics in topic 7.3 and move through data cleaning and data visualization. Finally, we'll walk through how to conduct comparative analyses and regression analyses in Stata, and your final data analysis session will be in person. Let's begin with topic 7.1, Getting Started with Stata. The objective of this section is for you to gain a basic understanding of Stata statistical analysis software. You will be able to recognize the parts of a Stata screen, see and set a working directory for your data so that it's easy to access, create and save a log file of commands performed and a do file, which is your syntax, open and save data files, as well as import a dataset and explore variables and data using Stata. Stata is a multi-purpose statistical package with which you can explore, summarize, and analyze datasets. We consider a dataset to be a collection of several measures of information called variables, which are typically arranged in columns, and each of these variables can have one or several values or observations for one or several cases. You may be familiar with other statistical packages such as R, SAS, and SPSS. Stata is widely used in social science research and is a powerful and useful tool for manipulating, analyzing, and visualizing data. Other packages, such as R, are free to access, but much more difficult to learn than Stata or SPSS. Stata takes a little time to learn, but it is also affordable in that a license is perpetual and you only need to renew when you upgrade your package. This is the home screen for Stata version 17. If you are able to follow along with a version of Stata, that would be helpful, but you can always refer back to these slides for practice when you have access to Stata. The central window here is the results window. This window will display the results of any commands that you run. This is the command window, where you can type the commands that you want Stata to run on your data. To the left of the screen is the history window that displays the recent commands you've run and any errors that occurred while running them. On the upper right side of your screen is the variable window, where you can find a list of the variables in your data set. Below this, on the bottom right, is the properties window, which displays characteristics of the variables in your data. The first step to take in Stata is to set your working directory. This is the path to whatever folder you would like to store your data in as you work in Stata. In these slides, the text in red is the actual text of the command that you type into your command line, and the text in blue is the text that you type into the command line that is unique to your data. The bold black text is what Stata returns in the results window when you execute the command. To see where your working directory is, you can type pwd, and Stata will return the directory in which your data will be stored. In this example, we have a directory in the H drive called Stata Data. If you want to change this directory, you type the letters CD for change directory, and then the file path to whatever directory you want to use for your Stata project. In this example, we're changing the directory to the C drive in a folder called My Data. If your directory name has any spaces in it, for example, Stata space and space data, then you want to put quotes around the entire directory path. The next step is optional but recommended, and that is to create a log file. This is essentially Stata's built-in tape recorder where you can retrieve your work and keep a record of your work. To do this, type into the command line the text log using, and then the name you would like to give to your log file. This will create the file, in this example, mylog.log, or whatever you choose to call it, with the .log extension in your working directory. You and anyone else you share it with can read it using any word processor, such as Notepad, Word, and such. But you must save it as a log.log to keep it in a universal format. If you use the point and click window to start and save the log file, the default is to save as a .smcl file, which requires a special program to open. So to close a log file, you can simply type log close, and to add more output to your log file, you can type log using and then your file name append. And if you want to replace a log file, you can use the above command with replace, but note that this will delete the contents of your previous version of the log. The next important step in setting yourself up to work in Stata is to create a do file. This is essentially your syntax file, where you'll keep all of the commands that you write and run. Do files end with the file extension .do or do. It is strongly recommended to use do files to store your commands as you work. This way, you do not need to type them and create them again when you need to redo your analyses or run data cleaning on an updated data set. It also helps you to know how you created variables or ran certain analyses. As I put in the title, please do the do. You can start a new do file by either using the point and click menu or by typing do edit into the command line. You can save your comments in a do file by putting asterisks around any comments and use forward slashes to separate lines. I'll show you an example on the next slide. You can see in this example that I've created a do file and began the comments in it with asterisks, then continued each line of comments with 2 forward slashes. You can do it several ways, but this is how I like to create comments. And you can find this do file in the same folder with your presentation, or perhaps the team has provided you with a copy of the do file. To open files that are already in the .dta format and file extension, you can either use the point and click menu by going to File and then Open and then navigating to your data, or type the command use and then the file path to your data file. If the file is already in your working directory, you can type the command use and then the name of your data file. To save your data from Stata, you can use the menu by going to File and then Save As, or simply type the commands save, replace. You can open or input CSV or other tabular data, comma-separated data, in Stata using either the use command in the data editor or by using the drop-down menu to select File and then Open or File and then Import. You can use the Clear command to remove previous data from Stata's memory, and the CLS command to clear the output window for a fresh start. You can use the command look for to find variables in a dataset. It works like a search function. For example, if you want to look for variables that refer to education, you can type the command look for in the command window, followed by the first four letters of education, EDUC. In this example, and Stata will find the keyword EDUC in variable names and labels. You might need to be creative to find the variables that you need, but you can always refer to the codebook that might come with the data to find your variables. If we use the look for command with the stem EDUC for education in the mix data, we can see that there are 5 variables that include the word education in their description, including highest level of education attended, mother's education, and variables measuring attendance at early childhood education programs. You can also use the variables window in both the data editor and the main Stata screen and simply type EDUC into the search bar and you'll find the same variables are selected. However, this will not print your action into the results window, which you might want to have to save for your log. The describe command provides a general description of the dataset and the format for each variable type. You can type describe into the command window, and the information will print into the results window. It will tell you both the number of variables and the number of observations, and it will list the variable names, types, value label, and variable label or description. To calculate frequencies of values of a categorical variable along with their proportions and the cumulative percent, you can use the command tab in the command window and then the name of your variable or variables that you would like to explore. Here we typed tab with the variable ED5A, which is the highest level of education attained by the participant, shown in the top table, and in the bottom table, the frequencies for ME level, which is the variable representing level of education of the participant's mother. You can use the command table to produce frequencies and descriptive statistics per category. You can type the command help table to get a list of all statistics that you can run with the table command. For a simple example, in the mixed dataset, the variable for sex or gender is HL4. So if we type table and the commands listed above with HL4 as the variable for sex, we get a table of just the frequencies of male and female sex in the mixed sample. And we see that we have 621 males and 560 females. You can see in this example that by adding a few simple commands using the term statistics, we can get information about the means and standard deviations of several continuous variables displayed for each gender and in total. There are many ways that you can use the table function to visualize and understand how multiple variables are distributed in your data. You can use the tab function again to create crosstabs, or a table of categorical variables in both the row and column. By adding the terms column row in the command line, you ask Stata to provide the column and row percentages in the data. In this example, we look at how mother's education level is distributed by region of Lao PDR. This is not testing differences in proportions by region. It is simply looking at how mother's education level is distributed in each region. So now you should be able to open and import data in Stata, describe your data set, find variables in your data, create tables of means and frequencies of variables, and evaluate the distribution of variables by other variables. If you have access to Stata and the mix 10% sample, see if you can reproduce some of the tables that are in this presentation. Thank you.